Have your science notebook, your pencil, and any colored pencils, crayons, or highlighters as we're going to be learning new words today. So let's go ahead and get started. I'm going to share my screen with you. And today we're going to be finishing up our study of plants by making sure we understand how to construct a scientific experiment. Now, over the last 3 weeks, 4.5 weeks actually, we've all had some really good experience with doing virtual labs. Today, we're going to dig a little bit deeper into what you are actually manipulating or testing while you're working in that lab. So let's go ahead and get started. In our notes, if we would please write investigating variables in a plant experiment. That's what we're going to start learning about today. Investigating variables in a plant experiment. It's important for you to know that this lesson is being recorded. So if I go too fast or you need to hear me explain something again, this recording will be made available to you in our orange folder and on YouTube as soon as our class concludes today. So we're going to be investigating or experimenting with variables today as it pertains to plants. What can help plants to grow and what can keep plants from growing? We're going to look to answer those questions today. It's important for us to know that a variable is a measurable change or outcome in an experiment. So it's something that I, as the experimenter, I am changing or I'm observing happen. Okay, I'm observing what happens at the end. We want to make sure we understand everything you see here, you need to be writing down. There are 3 types of variables that we will see in an experiment. The independent variable, the dependent variable, and the controlled variable. Please write this down now. Ms. Neville's going to take some time as well to be sure that I explain to you some abbreviations you may see Ms. Neville use when we're talking about these variables. So the independent variable, you'll usually see Ms. Neville abbreviate that as IV, capital I, capital V. The dependent variable, you'll usually see Ms. Neville capitalize as DV. And the controlled variable, you'll see me abbreviate as CV. Ms. Neville will be going on in a minute. So all of us can think of variables when we think about an eye exam. Most of us have been to a nurse's office at school or a doctor's office and had to have our eyesight tested, okay? What factors can affect what letters we see? So if these letters are very clear to me, it could be I'm closer to that chart, the distance from that chart. You do not have to write this stuff down right now. The distance from the chart will affect what I can see. The eye that we're testing, the left or right eye. Some eyes are stronger than others. For example, my left eye is much stronger than my right eye. Okay, so when we see here, these are some factors that can either help us to see those letters clearly or keep us from not seeing those letters so clearly. What we just talked about here, these factors, yeah, y'all, these are variables. These are variables that can cause change. Specifically, these are independent variables. So in our notes, let's write down independent variables. It's important for us to know that an independent variable is the variable that you can change. It's the variable that you have power to change. The variable that makes everything different is the independent variable, okay? Let's look at this glass of iced Kool-Aid. And let's look real clearly here at this question here. You do not have to draw this example or write this bottom question. Let's say that this started out as just red water that's been sweetened with sugar. And it had ice in it. So cold, red, sweet water. Someone unmute themselves and tell me, what would I have to add here to make this Kool-Aid? It's already sweet, it's already red, it's already a liquid, and it's already iced and cold. What do I need to add here to make it Kool-Aid?
Sugar.
Sugar's already in there.
Fruit or the main ingredients.
That flavor. The flavor is what we need to add there, okay? So the flavor that comes in, if it was just sugar water, it would taste like nothing, just sugar, sweet water. But the flavor is what gives our Kool-Aid here its signature flavor. So when we would add that powdered flavor, and we're going to draw a little picture of it here, a little pile of that red flavoring. If we were to add that into our cold, red, sweet water, that's going to be what makes everything different. This flavor is our independent variable. It's what I have control over. I can add more flavoring to make it taste more like cherry, or I can add a little bit less flavor to make it taste less like cherry. I have control over how much flavor goes into that Kool-Aid. So this flavor powder is my independent variable. A dependent variable is the ending result or outcome. So it's what happens when that independent variable was added. So let's look at it like this. If I have, and you will want to draw this, guy, so I'll stay on this page for a while. If I have this glass here, so if I have this glass here of just plain water, I'm going to write H2O, because we know now that's the chemical abbreviation for water. If I have this water here, okay, how will I make this? How will I make this into flavored cherry Kool-Aid? What must I add? Someone unmute themselves and tell me.
Flavor.
Yeah, I've got to add that Kool-Aid powder. Okay, so we're going to draw. Hopefully you got your color so you can make your notes attractive. Now, someone again unmute themselves and tell me, what did I add here that made everything different?
Kool-Aid powder.
The Kool-Aid powder.
Kool-Aid packet.
The Kool-Aid powder is what I added here. So the Kool-Aid powder is going to be my independent variable. Now, the ending result is my Kool-Aid drink. This is my dependent variable. This was my outcome, my ending result. So the finished drink is my DV, my dependent variable. My independent variable, that's what I added. That's what I had control over. That's what made everything different. The Kool-Aid powder was my independent variable. Please take some time to write this top stuff up here right now. We'll move down to the bottom part in a second. So let's stay with this example. Let's stay with this example and move down to the bottom part here of our, yeah, I like this color. That's fine. Actually, let's use purple. So when we're looking here, a scientist, I have to be able to compare the change. How much cherry flavoring is in that drink? How sweet is this Kool-Aid drink? I have to be able to measure the change by comparing its first steps. What did it look like before? What can I use to compare the results? That's where our controlled variable comes into play. The controlled variable is the thing that doesn't change. It's the thing that scientist keeps to the side to compare the ending result with what it was in the beginning. So if we look here at our example, what is our controlled variable in our Kool-Aid experiment? Someone unmute themselves and let me know. It's going to be our water. Think about it. We're going to compare our clear water with this red, sweet, cherry flavored Kool-Aid drink. So the controlled variable compares the results. I want you to make a little sign like this at the bottom of your paper, right beside controlled variables, and put up two hands. The controlled variable compares the results. The controlled variable compares the results. Okay, so I've got to have that controlled variable there because it shows me my progress. It shows me what actually changed and how much changed. Take some time to finish writing this down. We'll be going on at 12:48.
Hi, Miss Campbell.
Hey, Emma, if you'll mute yourself for me, sweetie, you and I'll talk after class, okay? Thank you. Okay, so let's keep going here. When we're talking about that controlled variable, and we've already drawn this, we see here that the controlled variable helps to compare our results. I'm able to see how much my water changed when I added that Kool-Aid flavoring versus what it was before. So I keep a plain glass of water there. That controlled variable I don't test on, it stays the same, okay? So important facts to remember. Let's write this down in our notes, please. We can, and I actually want you to put a star beside this one, guys. We can only test one independent variable at a time. We can only test one independent variable at a time. Why? Let's look at an example, and you don't have to write this example. Let's say I have a sick puppy. My dog is sick. And I just changed his dog food, and his stomach has been hurting. He's been sleeping a lot and all of those things. So I want to test, is it his old dog food that was making him sick, or is it the new dog food? Turn your mics on and let me know. Would it be a good idea for me to try to mix both of those dog foods to see if that makes him sick?
No,
No.
ma'am.
No.
No.
I need to test one dog food at a time. It's either going to be the old dog food or the new dog food that is going to make him sick. So I'm going to test him with the old one first. For a week, I'll give him this one, and I'll write down what happens. Is he running around and playful? Is he happy? Or is he still sleeping a lot? Then I'll try in the next week, I'll try just the new dog food. I can only test one independent variable at a time. One independent variable equals one dependent variable. I want to be able to see the outcome. What will happen if I change this one thing? Let's look and see what Miss Neville means. Let's go on in a second. I'll give you until 12:52 to finish writing this down. Remember, you didn't have to draw the dog food pictures or the sick dog. You just needed to write that star statement there that Miss Neville underlined a bit. Okay, so let's look here at an experiment together, and you're going to be testing your knowledge on this a little bit more. You're going to be testing your knowledge on this a little bit more on Thursday. But I wanted to show you a gizmo that you're probably very familiar with. Let's look at our growing plants gizmo. We're going to see here, as soon as it loads, my computer's being slow, y'all, sorry. We're going to see here that there are lots of different variables that we can test. Naomi, can you see my screen?
Yes, ma'am.
Okay. So there are lots of different variables that we could test here. The light can affect the plant's growth. The type of soil we use could affect the plant's growth, and the amount of water we put in the plant. All three of those things are independent variables. I can't test them all at the same time. Let me say that again. I can't test all of these at the same time. If I want to measure how much light will affect plant growth, I have to keep the water level the same and the soil type the same, use the same type of beam, and test my lights. Let's see what I mean by that. So with this, I'm going to be testing with our tomato plant. So all the types of seeds have to be the same. And today I'm going to measure, this first time I'm going to measure light. Will light affect how much this plant grows? If I'm measuring light, can somebody turn on their mic and let me know, can I mess with the water levels?
No.
No. I can only test one independent variable at a time. So let's see. So we're going to allow this to go. And we're going to be able to see some changes in each plant here and how they look. So after 50 days, each of our plants have different heights and different weights, how heavy that plant is. So I'm able to see that which plant is going to be the healthiest. How much light makes the plant look the healthiest? You can unmute yourselves and tell me. Which light, 1, 2, or 3 lights, helps the plant look the healthiest?
Plant 1.
Okay, plant 1's kind of greenish brown though. If I were to ask this, because that was a terrible question, I shouldn't have asked it that way. Which plant looks like it has the widest leaves?
Plant C.
Plant 3. Yeah, this is plant C here. So it shows us here that this plant is going to be the healthiest because it has the most leaves and it can make the most of its own food. Now, I'm going to reset it and I'm going to keep tomato plants. Now I want to test fertilizer. So if I'm testing fertilizer, there's one I'm not going to touch at all. We're only going to test plants A and plants B. Notice I've got all 3 lights on because I'm not testing light, I'm testing fertilizer. So the question I'm working to answer here is, how will fertilizer affect the growth of a plant? So let's see. Notice I didn't touch the water level. So after 50 days, what the plant with fertilizer, what is the difference with the plant A that had the fertilizer and plant B? What's the difference there? Someone unmute themselves and tell me.
Because plant A is taller.
Yeah, plant A is going to be taller. Plant A is also going to be heavier, okay? So fertilizer makes plants grow taller. You see what I'm doing here? So our last one that we're going to do, we're going to put our fertilizer back, is now we're going to test the water levels. This plant will get 20 milliliters of water a day. This plant will get 30 milliliters of water a day. And this plant will get 40 milliliters of water a day. Notice I've not touched the lights. I've not touched the soil. I'm measuring water. How does the amount of water affect the growth of the plant? Let's see. Look at the color of them as they come in. We want to think about those roots. Roots absorb water. So the color of that plant is telling me something. Okay, it's telling me something. Which plant weighs the most? Has the largest mass? Unmute yourself.
Plant C.
Plant C. That has to do with the amount of water that the roots were absorbing. Plant C is also going to be the one that's going to be able to live the longest because we see that this is green. That means it doesn't have much chlorophyll. And that means they won't be able to make their own food for very long. So we're going to be able to, on Thursday, you're going to be completing a lab report that's going to be for a test grade using